Hello, everybody. Good evening, good day, good morning. Turns out on the internet, no idea where, what kind of time you face. Well, it's 9:30 p.m. here anyway, so good evening to you. This evening, we are going to be looking at some introductory Rust, and I really enjoyed doing a similar tutorial last night, and in fact, it was my most popular stream ever. I had over 100 people viewing, so I hope not so much to replicate that, but definitely in terms of the numbers. But what I want to replicate is the positivity. So what we're going to be doing is working through some kind of classic computer science, or actually not even computer science problems, just kind of toy programs, and explaining how the Rust programming language works. If you have a toy programming language, or if you if you've got a little toy that you a toy problem that you'd like me to try and solve, potentially you could ask me to do so. I reserve the right to say, sorry, maybe another time. But I just hey to Sam, and hey Abu, it's great to see everyone. Feel free to ask any questions, and I will really kind of thrive off your energy. So when people are participating, everything becomes a little bit more dynamic. I can change what I'm doing. There's no set script. This is all done live. So if there's something you'd like me to expand on, just ask. It's the advantage of doing something face to face. Okay, so I'm going to introduce you to a website, and a website you've probably seen before if you have used Rust, and that is called what we call the playground. So the playground, I'll just post in the comments. And what we have here is a little space where I can compile some code. And I'll print a line to the screen, and that, what should we say? Is it hello internet? As good as I'm going to get. I don't necessarily want to do anything novel right now, but I hate hello world as an example. It's so trivial that we should find something interesting or new. So if you're brand new to Rust, a Rust program always has a main function, and if you exclude one from the playground, you'll actually receive a warning right away. And in fact, it goes and creates hello world as the boilerplate example, but we're saying hello internet. So let's talk about our very first program. So I am going to be doing the the amazing FizzBuzz program. So FizzBuzz is kind of this notorious example project which Joel Spolsky said that if you are ever doing a job interview and you want to be able to see if anyone can program at all, ask them to follow this rule. What we need to do is work from the numbers. I'll just kind of write it in pseudocode, like from 0 to 100. When a number is divisible by 3, I can't type as fast as I can talk. Actually, not when I have an audience. The divisible by 3. By 3, then I print fuzz or fizz with 2 z's. Oh, I'm really bad at the keyboard tonight. I guess it's nervousness, people, staring at you and so forth. I'm also just kind of clumsy, which isn't particularly helpful. People know this program, so I don't probably need to explain it all. When the number is divisible by 5, print buzz, and 15. print FizzBuzz. Otherwise, print the number. So this is kind of like a textual description of the program that we're trying to solve. So the immediate way to do this, if you are, let's start with something that is not idiomatic Rust. Or I in actually, let's say that we've got let I equal 0. And then we want to say while I is less than or equal to 100, we'll just start by printing I. Ugh, I really can't type. It's quite embarrassing. Luckily, I don't have an audience. So this is not what we need. We also need to increment I. Plus equal 1. This is something that is not idiomatic Rust. It's not going to get us what we want, but it's also going to fail to compile. The first point that I want to make about Rust is that Rust is not going to allow you to change any value once it has been set unless you mark it as mutable. Or so we add this mute or mut keyword to any language definition, and then we're actually able to print 0 through to 100. Now, I'll explain why it's not idiomatic Rust shortly, but let's actually solve the problem. So if if I modulo 3 equals 0, I divide by 3 and I have no remainder, then I wish to print fizz or buzz. No, fizz. If it's divisible by 5, buzz, I'm going to kind of cheat slightly and just else if I could have, and then we're going to do a third check, which if this is divisible by 15. There are smarter ways to do this. But again, this isn't really it's not an algorithms class here, or this is a Rust class. And otherwise, we print I. You'll note that, and I've got two ways of calling, actually, no. I'll just point out these exclamation marks, or if you're American, an exclamation point. You don't have to include an exclamation mark in every function call. However, this is a special type of function, which we're calling a macro. And a macro is a function that returns some code rather than a value immediately. Printing to the screen requires a lot of type conversion. We treat integers differently than strings, and so it's easier to implement printing to the screen as a, this is going to be an infinite loop, so that it'll halt itself. I need to actually increment 1. I'm quite surprised that it's not stopping. I feel sorry for whichever Docker container is kind of doing something needlessly. Ah, right. Interestingly, it didn't print FizzBuzz at all. So we have a logic bug in our code. So it's like compiler execution took more than, well, I guess it's 12 seconds, or is that 120? 120 seconds, so 2 minutes. Although someone can convert that 12,000 milliseconds to minutes. So this is actually logically incorrect. I can change it, but I just want to demonstrate that we are So it's 12 seconds. Thanks, Matt. Okay, so we're printing and we're buzzing, but this isn't super interesting. I want to make two changes. The first change that I want to do is to use a different looping construct. One that doesn't require me to manually increment the variable. The other thing that I could do is check the most specific. So Bill here has a very good point, which is that come on, Tim, check 15 first. I will fix the logic error in a different way with something that I think is a little more elegant very, very soon. But right now, I'm going to change the looping construct, explain that, and then we'll change the programming error. So I want to introduce the range. So instead of a while loop, I can use for I in 0 through to 100 with an equals, which is an inclusive range. So this whole little block, well, I say block, and this syntax here is an expression that returns this kind of range thing, and ranges can iterate through themselves. And this does not require you to manually increment values, which means that it's much more, that's sort of fail-safe. So I'm going to copy and paste what we had before with FizzBuzz. And then I'm going to fix the bug because now it's annoying me. I thought I could let it go. I thought I could let it slide. If we ask for the most specific first, it will work, I think. It would be embarrassing if it didn't. Okay, so it doesn't work actually. It turns out that I is divisible by 15 with no remainder. That's a very strange outcome as far as I'm concerned. I'm quite curious as to why that is a problem. So Sam actually raises a really good point, which is that can you use kind of a mapping construct? And the answer is yes, we can. I'm kind of like I'm trying to like show the light to people who are new to Rust. So this is a very, very nice hint that that there's something like quite juicy to come. Now, I think that, and actually my logic error is this other thing, which is that when you divide anything by, when you divide 0 by anything, and I starts at 0, you don't have any remainder. And so this first test will always pass. So we kind of have this kind of weird loop, this kind of strange logic error. I wonder if I should just start at 1. That will probably, that will solve it. We kind of changed the bug there. Well, we'll just change the problem definition as well, and then we skip the bug. And I like that people are showing, telling me, basically, this exercise of live coding is demonstrating that I can't implement FizzBuzz, which, like, is really. I don't know what that's doing for my confidence right now. Okay, let's get rid of these if statements. I want to introduce match to you, and that is I think actually the most elegant construct in Rust. It's very similar to a select statement, but it's much richer. And so basically what I'm going to do here is create a truth table. So each of these expressions, I've got 2 expressions that are paired up, and they become a pair of Boolean values. each expression returns a Boolean. And if they're both true, then I would like Rust to print FizzBuzz. If it's divisible by 3 but not 5, I would like Rust to, and I can use the underscore to represent some other value. We could also add false as well. Now this one's different. We need false over here. And lastly, if they're both false, then we get to kind of print here. Now, I really prefer match over a block of if statements or if expressions or whatever. So then we go, we get exactly the same result, fizzing and buzzing, and it's great. And the just had kind of like a quite a fun comment, which is like, well, why don't you make an enum now? And actually we could go type safe. We can kind of like, we can go to, this is kind of the next level of Rust. I want to try to see whether I can go back to a point that Sam made about like, can I use a map? And I'll show what a map is, and B, whether or not this is possible. I'm going to be doing this live, so this is not on my script, and I might look very, very embarrassed in about 3 minutes time. Hopefully you'll stay with me. Okay, so to do it in a purely functional way, Rust is kind of slightly unique from the point of view of systems programming languages, in that it really prefers to use it like it really respects functional paradigms. It's actually syntactically it's very C-like, but I sort of find it much more, or actually a lot of its internals are derived from the ML family, which is OCaml and Haskell. We've got this range still, and then we can actually put the map straight in there. Now, if we do this, we won't get the result that we expect, or at least that we might be expecting. And I will wait to see. Actually, I'm not going to wait. The problem is that, and I can't wait because I know that the compiler is going to tell me the problem, and that is that iterators are lazy and that they don't do anything unless you really want them to. And so if you haven't encountered map, which is unlikely these days, it's going to take one of these values as I and apply some function to it. And, or in our case, it's we're kind of using the expression that we had before, and we're plunking that in. Now, just at a really nice comment from Matt here, which is that you can swap out map for each, which is what I was going to do. So there's a couple of ways of solving this. For each method is very similar to a for loop, and most cases in which you are using a for each for just doing something like printing to the screen, idiomatic Rust would say that you actually revert back to a for loop. However, there are cases in which it's much more elegant to keep things inside of a chain of these iterators. So I could, for example, I don't know, enumerate. That's kind of weird. I've now got I and J are exactly this. So I is, I'm going to enumerate takes an iterator and adds the position of the iterator through. So I becomes 0, J will be 1, and then, or J is this map, and there are lots and lots and lots of different things that we could chain on. I'm not going to bother now. I think we've solved, actually, maybe we haven't solved FizzBuzz enough times. I feel like solving it one other time before I move on. Like, I don't think that you would have expected to implement FizzBuzz like 50 different times in this stream. Like, we can actually extract a lot out. And one of the things that I want to try and extract is this repetition. I have this kind of intuitive sense that actually that I could reduce the amount of repetition in this code. Is there a way to make it more attractive? And I think what we'll find over the next few minutes is that we can get closer to what we want. We won't be able to eliminate all duplication, but we can try. But the thing that I really want to demonstrate to you is that everything in Rust is an expression and returns a value. So even the for loop, actually at the end of this block, it returns an expression or a result. So by result, I don't mean the result type, which you might have encountered. So I'm going to do a bad job at naming here, and we're going to return, or at least we're going to try. We're going to try and return our strings. And then we're also going to want to try and return our integer. And then we'll want to print line to print. This won't work. And you probably have already guessed that the types are different. You have in this last line, or at least line 12, so there's a syntax error as well. I need to fix that. I expected a semicolon, but all I got was a... So I'll fix the syntax error to just prove that it won't work anyway. And now we have this problem that the match arms have incompatible types. So one of the things I want to demonstrate to you is that the Rust compiler is quite helpful. It's telling us exactly where the problem is and what the problem is. So it's telling us that these match arms, these first three, have different types than the last one. So how do I fix this? Well, I need to somehow, I could either try and convert these strings to integers, which seems like not what we want to do, or I can convert the integer somehow to a string. This will raise a particular problem, which is that there are multiple string types in Rust, and I hope that I'm not going to lose you when I try to explain the difference between all of them. So I'm just going to fix, or at least start to fix the problem. This, it turns out, will not work as well for a different reason. What the problem with... So I've got a toString method. So integers know how to convert themselves to strings. However, the problem here is that a string with a capital S is not the same type as this ampersand stir thing. Ampersand stir is also known as a string slice. So it is a reference to some array, some sort of string thing, whereas a string itself is what we call an owned type. An ampersand stir or the string slice doesn't actually imply that you own the string, the backing or string as well. So we've got a recommendation here, which is that we should consider borrowing, which just is we should just add an ampersand. So what we're doing is we're starting with I, which is an integer, converting it to a string, and then taking a reference to the string to actually get a string slice. So this will pass the type checker, but actually will fail for a different reason. And that is that the string that is being created right here will be deleted as soon as it gets to the end of the scope. So as soon as, and so there's no point in taking a reference to it because the reference is pointing to data that is going to be obsolete as soon as it's created. And the cool thing, so we're going to have to fight this. We're going to have to fight our way through. And I've actually just, so Sam's here got quite a fun kind of comment that I bet I have to explain the difference between string and str quite a lot. And you'll be right. I actually had to explain this so much that I created my own YouTube video just explaining what, what the difference is between a string and str. So that was cool. Now let's carry on. So I got ampersand str. We've got an integer which we're turning to a string, which we're turning to a string slice, but we need to somehow create a string that will last as long as we want it to. So there's another way out. This is kind of like a fool's. No, I said, so the comment here is that like, well, how could you? It's like somehow you've got like it's like a keyboard shortcut that you just paste the link in. No, I was actually I've got two screens, and in my bottom screen I've got the comments and stuff like your own message, and I was hunting frantically for my YouTube video. So I'm glad that it looked like magic. So there's another one. This is a sort of an escape hatch. We can cast string for all of them. So this is another way of, so string slicers know how to convert themselves to strings as well. And now suddenly we've unlocked the puzzle, or maybe we haven't. The problem that we're facing here, if you really care about performance, and that is not and that every time you call to string, you create another string, which requires a dynamic memory allocation. Now, if this term is new to you because you've only used like Ruby or JavaScript or Python or R or Perl or whatever, it just means that people that really care about nanoseconds of performance do not want to allocate strings. They don't want to do it. So if you are not one of those people, if you are one of those people, just call to string as much as you want. And there's another one that's quite similar called clone. And you can clone as many times as you want and offend many people because it's not elegant. So this is not an elegant way to do what we want. In fact, we've actually made the situation worse because what we wanted was just to remove the duplication, and what we've done is created more duplication, and we're like kind of weirdly obfuscated what we wanted. So I'm going to, in this case, maybe just calling print line is the way to go. I want to introduce one other pattern, and that is, what if you wanted to print out a batch of, instead of printing out every single iteration, what if we printed out once, but actually created all of our values inside of a string? And we've talked about mutation, so we know that we need to add mut, the mut keyword. Oh, mute sounds much more polite. Now, still actually going to encounter the same issue with our integer. Our integer is the wrong type. So I'm just going to leave that as, I wonder if I can, I think it supports, I wonder if I can, I don't think this is going to work. No, it got very confused here. because this is not a simple expression. I need to put it inside some braces. The problem that Rust has found out, or at least Rust is confused because I've asked it to do something that's more than one expression. So that becomes an ambiguous parse, and is asking me to what expected expression? Boo. Wonder if that will be enough. I doubt it will be. Okay. So I'm going to stop playing around with concatenation. I'm just going to. I'm just going to do the same thing. Expected. I just had a very good comment from Matt again. Matt's been showing me up a lot this evening, and I've got it the wrong way around. This is concatenate and assign. I don't know if it's going to work. Ugh, I expected another slice. Really? The other thing is that toPrint is now a string, and strings. Oh no, it's not. It's a different type. It's the unit type, which is kind of like a nothing value. We no longer care about the toPrint. We only care about printing out. And I'll just add some new lines in here. And one of the other things that I'm going to do, because I know that this toString thing is just going to cause a lot of drama, is that I'm going to introduce another macro, pushStr. Well, actually, we'll see. I think this will fail for the same lifetime problem. Oh no, hello, it was fine. Except, oh, we've got no spacing. All of our spacing is gone after our integers. So we might also need to push another new line. Okay, you kind of get the point, or maybe you don't. I'll add one. I feel like doing a different exercise. I'm going to push another character. Problem with doing things or wanting to fix things is that you get stuck. So I'd like derailed. So we can see here that strings do support kind of this concatenation thing with the like assignment, the operator overloading. And then there's actually another option as well. I've got a format macro. Oh, so we had a really, really good question. Is this /n thing like something kind of weird Unicode? And no, it's actually a very long-standing convention from many programming languages will use a backslash or a slash, sorry, as an so-called escape character, and then n represents the new line. So if I go, in some sense, it is Unicode. If we go to Wikipedia, Wikipedia will probably prove me wrong. I'll just be like escape character. For some reason, I remember seeing myself. So, for example, in JavaScript, it's the same. It's a backslash and then an n, and this is in many programming languages. Right. So, and there's this kind of other point, which is this won't work. That won't work on Windows, though, right? And actually, you'll be correct. So let's do something that let's show the world that that I know about Windows. Now, I'm going to show some kind of, this is slightly advanced Rust, but it's a good point. What if you wanted to compile a program, you want it to run on Windows as well as on, say, Linux or Mac OS? First of all, actually, I need to explain the difference between a single quote and a double quote. So a single quote is what's known as the character type, which is a single character, whereas a string slice is like an arbitrary. It can be an of arbitrary length. It's a bit confusing because you can have string slices that are also like of size of length 1. Now, this doesn't solve our problem. So just the question is like, well, how do you so the problem that we're facing, just to flesh this out, is that if I go to Windows and I look up new line character, it turns out that there are dozens of different ways to represent new lines inside a computer. There's no single standard. We've got the slash or \n thing, and that is almost a standard, but it's not ubiquitous, especially when you think about older computers. And I say older, anything pre-80s. So if you're like, or if you're on a mainframe. If you're running, if you're programming COBOL, you don't even have it. You don't have ASCII, for example. Oh, now I'm just going to say Mac OS and Linux. Now the problem that I've got is that I can compile this program once, but I don't want both to appear. I need to somehow tell Windows, I need to tell Rust that when it's being compiled for Windows, behave differently than when you're compiled for, in our case, say Linux or like anything. It will just say not Windows. How do I do so? And I'm going to get the syntax wrong, but I've got this. I'm going to check the Rust documentation because I don't want to get config, Rust config, and then OS Windows. I think I know it, but I want to get it right. And here we go. Thanks, Stack Overflow. So we can say that if we're actually in Windows, simpler than I thought, then add this expression. And the alternative is like, if we are, and there's no else here, it's not actually a conditional, it's known as it's a syntax extension. It looks like Rust, but it's actually an indication to, like, but I can do config not Windows. Be more specific and ask for specific implementations of things, but I think that this is what I want. Notice that there's a different method for pushing a character versus pushing a string. Hopefully that answers your question, Sam, that when we're writing cross-portable code, we can add these little blocks which change the behavior. I wonder if I can compile to a different operating system on side. Probably not. That would be kind of crazy. Anyway. Okay, so I've spent now 40 minutes on FizzBuzz. I think I did have some more fun things to do. Right. So, do I want to give an example? Like, would people prefer to see an example that I'm 90% sure. Oh, by the way, I'll share the code so that you can play too. So this is so this is the link to the code where I'm at right now. And I've just had another question. Is there not an equivalent of stirred end L? It is in there. So if I go to the Rust documentation, so Sam is referring to a C++ standard. And if I go into stud for Rust and do in like in the OS module, there are some constants in here. Oh, that's just talking about its environment. I don't care so much about that. It's in there somewhere. You have like it's inside standard stud OS, and I think I actually don't remember. There is somewhere to find an abstraction which says that I just want the end of a line, and do the right thing depending on where I'm being compiled for. Okay, cool. Now, so I've got some decisions to make. One of the decisions is like, well, what am I going to do? So I've decided to do something that I haven't implemented for myself, but I'm quite keen to, which is this dice roller. And I'll stick up the banner. Example, dice roller. I took the time to create these banners on the system. I may as well use them. Okay, so if you've ever used? I've only ever played Dungeons and Dragons like once or twice in my life. But if you read if you are a dungeon master and you need to select which the story that you'll create involves rolling die all the time, like rolling dice all the time, and there's this notation that they've established, and the notation is that you have a number or two integers, and they are kind of bracketed or delimited by a D, and so this would be roll a six-sided sided die. A roll. I'm probably going to. Whereas this one is like roll 3 12-sided die. Now, feel free to, if you are a Dungeons and Dragons fan, you can correct me if I've got this flipped the wrong way. I'll pay for it. I'm sure that you'll comment. So I'm just going to clear the screen. I'm going to be doing this live. I have a partial implementation, but not a complete one. So I saw this in a coding challenge, and I've wanted to do it myself for a long time, but I haven't really been bothered. So, or at least I've been busy. So let's start with. So what we want, let's program from the inside out. We want the kind of a parse method. Then in here, we want to right. Okay. So Sam's actually pointing out, like, we call this as like a D6, which is like a six-sided die, even though it's 6D1. Anyway, so that's kind of fun. Right. Okay, so let roll. We're going to pause and then roll. And I'm going to sort of, so what I want in this part, so this parse method, will take a string, turn it into a type, which then knows how to roll. I feel like this is an API that I think I'm happy with. could just bundle them into one method. And actually, I'm just realizing if I've got time, what I might do is extension add plus 10. So we'll see your add an in terms of like tiredness, add an extra method to string. Maybe we could just teach strings how to roll a dice. Sounds kind of weird. It is, but maybe I will be able to show you what that means. Effectively, there's this mechanism in Rust called a trait, and we can actually extend types from the standard library with traits. Okay, so I'm going to start with a struct. I feel like they should be called struts. You know, we got this roll thing. Maybe is that a funny joke? I don't know. And we'll just go. It's like a U32 or like we don't need that much. We don't need and insides. So the I'm going to implement the easy. Well, maybe the easy thing. First, actually, we'll implement this parsing thing. So, like, how do I convert a string to a roll? And it turns out that there is a trait called FromStr. And its job is to parse a value from a string. So that's kind of exactly what we want to do. So to implement it, the first thing that I need to do is bring it into local scope. Also just going to copy from pull this out over here. And then no doubt it'll disappear, which is not useful. Ugh. Just going to copy a little bit while we get started and kind of get the base. Sys. Actually, sorry, I'm confused, everybody. What I need to do to implement FromStr, it's got a bit confusing. I need to define an error type. So the one thing about parsing is that parsing often goes wrong. So there's always this case where it's probable that you will make a mistake. Or at least the input that you receive won't be of the form that it requires. So you also always need to be able to deal with errors. In this case, the FromStr method is actually using an error type from another module. So it's actually saying that the I32, like the parsing int error, is what they care about. In essence, this implementation is ignoring the possibility that there might not be brackets or parentheses or a comma. So errors in this part are actually silently ignored. Now, you may also recall that I called my method parse. It turns out that FromStr and parse are sort of inherently linked, but they're distinct because of reasons which I haven't quite understood. It turns out, though, that parse can parse any type that implements FromStr. And so it turns out that to enable parsing, we implement FromStr. I think what's happening is that I implement FromStr for a given type, but actually it's the parse method of strings that I'm calling, which kind of is generic over every type or every every output type that implements FromStr. So I think that's why they're distinct. Okay. There is a lot going on. Let's kind of actually we'll cheat. Let's cheat. I'll bring away my tweets. If anyone wants to hang out on Twitter, by the way, you're more than welcome. What I'm going to do, I am perfectly happy. I have no shame about taking the original, like the code from the documentation, and just copying and pasting it into my own code. Like honestly, it's the easiest way to do it. Now, although we've got a couple of things that we need to change. First of all, we're not implementing it for point. We're implementing it for role, because that's our type. We have no error type, so we're just going to say. So what we now need is an error type. We could just use a string. We can actually nominate any type that we want to mean an error. I'm just going to say, this is a bit, just kind of create like an anonymous type. And I've got a cute name. It's actually, we could be more precise later, but we just say that if there's an error, it's a bad roll. So all of this is junk. We don't need any of this. Then actually we could hold on to a little bit, because actually it's almost doing exactly the same thing. We don't need to trim anything. I'm just going to add though the trim call in case there's white space. So we could say we could tolerate white space. And then instead of splitting on a comma, we will split on the D. And then we're collecting it into a vector, which is exactly what we want. I wonder if I should try and make that more precise. Now these are no longer coordinates. These are let's call them specifications, because we're being pedantic. And this is no longer a U, an I32. This is now a U16. We're no longer returning a point. We're returning a roll. And the number of dice is on the left, and the number of dice is on the right. So the first one is the number of sides. Then the number of dice is on the right hand side. Now, when you have variables that shadow or mirror the names of a struct, you can actually just use the variable names themselves. If you've got things different, you need to actually say which is which. Now, I wonder if this will work. Highly unlikely to work so far. Clearly, the very first line has a syntax error, which is exactly what one would expect. Okay, so parsing error. Okay, so this thing is a bit of a problem, and well, it's not really a problem. This parse, so we're actually deferring to something else's parse call, is going to return this parseInt error that we saw earlier. So we need to convert any errors that bubble up there into our own error type, because we can only return bad roll. We can kind of parameterize this by making it more specific, but right now I want to go to bed, so I'm not going to do that. Instead, I'm going to kind of have this kind of crazy pattern where I call or else, which says that if you attempt to parse an integer or an unsigned integer that's 16 bytes long, and then return, and it's successful, please return insides. Otherwise, or else, and I'm going to ignore that. And so this is actually a parse_int error. We're going to ignore that. And I just want to turn error. And then I've got a bad roll. I think this will work. We'll see. I'm sort of short-circuiting things here. And it turns out that this question mark is also a short circuit operation, or sort of syntax. Oops, that's not going to save. I wonder if this will get closer. So this is saying I expected a U16, but I found a result. Oh, so I need an unwrap call in here. I wonder if I can just add the question marks, because I've now converted any error to a bad roll. And I wonder if I can just remove these returns. Because the question mark will return the error that gets found. Okay. So the problem now is that FromStr, I've got a result. Is that this parse down the bottom on line 36 returned the result, and so I need to unwrap it. Ugh. And now it's saying that, okay, so this is annoying. Well, it's not really annoying. It's useful from like your actual programs. I need to, and one of the things about unwrap is that unwrap will print out a debug message when something crashes. And what Rust is telling me is that it doesn't know how to print out a bad roll in a debug message. So there's no point in using it as an error type. So thanks, Rust, for having my back on that one. We'll see if that's enough. I don't think it will be. We've got lots of compiler warnings, which is okay, but actually it compiles fine. So if we want to do anything with our roll, I should get a better variable name to start with. So we now have, we'll just implement debug for that as well, so I can print out the actual thing. So we just verify that we have got what we want. So we should have one 6-sided die. And to ask Rust to print the debug method, we start with, we add these kind of colon and question mark. It's kind of a formatting operation word. Again, not a computer science class, much more of a Rust class. So one die and 6 sides. Now, how do we roll? Okay, so the other thing we want to implement is the other side of the API. So we've got here a roll method that I wish to call. The roll type signature or type information to parse needs to kind of move into the parse method itself via this what they call the turbo fish syntax. So if you hate it, sorry, I found it fun. Think of this as a fish. It's like flying through the water. It's a turbo fish. We don't actually have a roll method at all yet, but this total thing is going to be an integer of some kind. So we're just going to return U32. This will be the sum, like we're rolling the dice on the board, and then we're summing up all of the results. So how do we create a method? We create a method by defining a function inside what they call an impl block, and the impl block will roll. So sorry that I've got a variable name, a type name, and a method name, all with exactly the same name. Fortunate. Now this roll method of the roll type needs to take a reference to self, and so that we denote that with the ampersand. And then we want a random number generator. So I need to bring that in. I believe it's rand RNG. And when I roll my dice, I need to create a random number generator. Oh, so this is a bit confusing, by the way. I'm pulling in the module and a trait, so that the only way to call, so at the start of this discussion, I mentioned that we're actually we're actually using traits to extend types, but I can only do that for traits that are in local scope. So I need to bring the module in so that I can access this function, read RNG. But I also want to expose the types. I want to be able to call this RNG gen range thing later on. So what I will do, and this is going to be between 0 and self.insides. This will be for any given die. It will have a value at the end, actually between 1, because there's no die that has that has a 0 value, and inclusive of the number of sides that it has. The way that I get gen range available to RNG is by bringing in the RNG trait. Now, instead of having this on 2 lines, I can use a kind of a shorthand, just kind of bring in the self. Is it an attribute member of the rand module? So this is a different type of self. This does not refer to an instance of a type. It's actually just self in the context of a module. Right. So we saw kind of a neat little syntax, which is ranges and mapping. I think I'm going to use that again. It doesn't really matter. I don't care which die it is dealing with. I just want to return an integer. Then I wish to sum it. Sum all of those values up. I also need to say that this is going to be a U32. Oh, so I'll also coerce the type. I wonder if how close we are here. I feel like, oh, we're closer than I thought. So we rolled 1 6-sided die once, and we got a 6. So and that's kind of fun. So our other example was a 12-sided die, where a D12, and we want to have 3 of those, and we'll roll them. So this should be we should get a total value between 3 and 36. It's taking a long time to compile. It's always a good sign. Yay, we got 22. So, whoever, we kind of got somewhere in the middle, which was what we're expecting. I did mention that at the start of this little block of, the start of this example, was that we can actually extend standard library types. So what we've got here is we're trying to parse a dice roller from like, so here's our syntax. And we've got this parse thing. We need to unwrap, and then we call roll on the struct that we've created. This is kind of arguably it's kind of an overkill of an approach. I think it's probably quite sound as a software engineering approach to kind of create a type that defines the behavior that we want. But let's say because we thought we were sort of super special, that we should extend string to actually be able to become a dice roll itself. Like how would we do so? We'd do that by creating a trait. I'm just going to call it something different, which is going to be, the trait is going to be called D&D roll. I wish I had a better word. Now we want to have a function roll, which takes a reference to self. And then we've got a choice. We can either provide a default implementation, or we just leave a type signature there. In our case, we're just going to leave a type signature, I think. Yes, because inside the trait, we don't define any associated types, or we've got no other information. So we can't actually, there's nothing that is compelling anything that implements the trait to have like an end dice or an end sides like fields. These fields are, we could just implement D&D roll for $stir. We'll just do it with a string on it. But to implement a trait, we copy out the type signature. And there are, in this case, we'll just roll one. And we can put whatever we want in here, and then we'll just try roll. We should just get a die roll. It should print one. Otherwise, I embarrass myself, which I've done a few times tonight. But that is how you can extend types from the standard library with your own behavior if you want to. It's kind of in some sense, so this is not kind of monkey patching, but I guess it's close. I'm going to allow you to figure out how to wire everything together so that you could actually do all of this behavior inside a single method if you really wanted to. It's just a matter of gluing all of the bits that I've got. So here is the text of, here's the text. Oh, sorry. Here's the link to the code. That's useful. And now there is now time for a couple of minutes, actually, for questions. So, so Sam actually has quite a good one, I think. Is that, and he wanted to be polite and not interrupt me, which was cool. That how do you find out all about all of these kind of things like derive and derive debug? We had a struct here before called bad roll. I don't know if there is a I've just kind of learnt them by rote. And there is a piece of documentation called the reference. Now, this is kind of a bit ugly, and it's quite it's not the worst language reference that you're going to find, but if we search for annotation or attribute, these things are called attributes, not annotations. So we have the syntax here, and one good thing to know is built-in attributes. There we go. I'm just going to post a link in the chat to built-in attributes. So there's a long list of about 20 or 30, which is probably the bulk of what you need to know right away. Or at least if you care about Rust, you'll probably encounter. And that, and are there any other questions? I think this is quite a funny comment, actually. I just try to make everything debug and derive debug out of all the code that I write. And me too, really. But there is one downside, which is that it does involve more code generation and potentially fractionally smaller or fractionally longer compile times and bigger binaries. Hey, this is a really, really nice comment. Thanks very much, Sam. Is there a multi-edit function in the Playground editor? No, the Playground is very annoying as a code editor. I like to use the Playground because I want all of these learning materials to be very accessible to the audience. I don't think that you should pay money to, well, I don't think you should be required to pay money for tools or use professional things if you're learning something. And so I want everyone to feel like we can learn together. And unfortunately, the Rust Playground isn't a very good editor. It's not terrible, but it's just a very it's just a very bland environment. It's just a text editor. Okay, and I think that is everything from me. I am going to wrap up. I really enjoyed hanging out for an hour and a bit, and I encourage you to hit follow and subscribe because I get internet points, I think. And I am very, very welcome. I'm very open to creating a stream on different topics. So one of the things that I was asked last night was to talk about different libraries and maybe explore some of their internals, which I think could be a very interesting set of streams. And the other thing that I'm interested in doing is just basically using kind of a showcase of some of the things that people have built with Rust. It's probably quite obvious if you have encountered me, if you've discovered me. It's probably quite obvious that I'm the author of a Rust book, so I always have this bit of a Rust bias, but hopefully it's still fun. And I don't necessarily think that you should feel obligated to buy my material. However, if you did, I have a code for you. If you use I really can't type now. Here is a coupon code. Yay! Thanks very much, Sam. I will. Yeah. So let's pump the book. Here it is. I've. It's actually. I hunt from I Google myself. I Google a book quite a bit. I'm trying to find reviews and so forth. So I've got quite a few links on my favorites. Naturally, it takes like 6 years to load. So this is the book that you're looking for. It's received quite strong reviews, and I can only promise that 94% of people that buy it give it a 4 or 5 star rating. Sadly, I can't give you 100% rating, and I'll just swap the thing so it's a little bit easier to see. And yeah, so this is my book. I really appreciate everyone's time. I am going to go. Oh, wait. Have I given you a link? Probably not. This is a wonderful comment that like it's delightful to hear. Honestly, I'm absolutely ecstatic that you've made this comment, that you can now, like, with with Rust in Action, you've actually been able to build something, and Rust is no longer theoretical. I think it's just absolutely fantastic, and I am ecstatic. So with that, I am going finally to say goodbye. Thanks everyone again. It's really been like quite a fun evening. I'll see you later. Bye bye.